Welcome everyone to another lesson on Khadija Academy. Before we start this lesson, hit the subscribe button, the notification bell, and the like button for the YouTube algorithm. Now let's go and start our lesson. Now, what are exactly the control goals of a static synchronous generator? We just explained it. We said that we would like to control active power, right? How much active power, real power giving to the grid from DG to the grid. We also said that we can control reactive power, right? To how much Q is given from DG to the grid. Now we have several options. Remember that our system, our generator in general, has its rating is measured in apparent power, how many volt ampere, right? S, or apparent power, which is consisting of P, which is active power, plus JQ, or reactive power. So we have active power, which is the real power giving us mechanical work, and Q, which is the reactive power used for excitation, right? Due to the presence of XL in the transmission line, or due to the excitation of the machine itself. It needs reactive power. Okay, so as you can see that if we decide that our machine, our inverter, will not provide any Q, so the power rating of the machine will be dependent on the active power only. So in this case, we will have a small size of the inverter and low cost, right? Because only we are passing here active power. Q is equal to 0. Now for if this DG, if we have a load here, then our DG or distributed generator, the Q, it gives the P active power to the load coming from this generator, and the Q of the load required will come from the utility itself, right? So in this case, the DG will work at unity power factor as a generator. You can see 0 reactive power coming from the DG, so it means that it only provides active power, so it is working at unity power factor. Usually it is not the case, because this Q is representing a load on our utility, right? Or it can cause power quality issues, or reduces or increases power losses, increases voltage drop, as we learned before, when this Q travels from the utility to our load. So what we are going to do is that our generator here will not give zero reactive power. It will give us the Q also required by the load. So in this case, the size of the inverter will increase, because this inverter will have more power rating that will allow this Q to pass through it, right? So in this case, it will give Q load will go here to our load, and we will not take this from the grid. Okay, since we are having greater S, it means that we will need large inverter and high cost. Okay, in this case, our grid will work at unity power factor. Why? Because we don't take from it the Q. We only take reactive power if needed. Okay, however, in reality, we can also change how much Q we can give. It is not necessary Q load. We can give more Q if we would like to support the grid. Another way is that you will find that Q and V at the point of command are coupled with each other. So by controlling reactive power, you can actually control the voltage of point of command coupling, right? So by controlling here the reactive power here, we can control the voltage here, because they are related to each other. We will explain this in the next lesson when we talk about the active and reactive power for a synchronous generator. So we can have two options, or we have many control goals of a synchronous static synchronous generator: controlling of P, active power, controlling of Q, or controlling of VBCC. The other function is synchronization with the grid at the BBC. So we would like to synchronize with our grid here. In order to synchronize, we need that the three-phase voltages must have the same frequency, must have the same amplitude, must have also the same phase shift. These are the synchronization conditions which will be done using the control system too. All of this in the same controller. Another part which is optional or ancillary services is that we can control the power quality level. We can do the mitigations of harmonics, unbalance in the electrical systems, and the voltage sag. Okay, these are optional, which we are not going to focus on them in this course. What we are concerned with is how to do this main goals. Okay, so let's see how the control loop will look like. So as we said before, we will have a control system. This control system, what it will control some goals. Number one, it will control the B reference, active power reference, what active power you would like to supply. And we would like to control the reactive power or the voltage at point of common coupling. What is the reference value you would like to get, or the reference voltage you would like to get, this or this. So let's say I would like to control Q and I would like to control active power. So by using this in the outer loop, this is in the outer loop, we will get the reference, or before this, we will use scalar control or a vector control to get the required reference currents or reference voltages from these reference values. So what I mean by this, if I have P active power and the Q reactive power, these are the reference values that I need, right? Okay, which I select by the controller itself. What I would like to do, how much power you would like to feed to the grid, how much reactive power you would like to give, or zero reactive power, as you would like. By using these two values, you will get what kind of voltages or what kind of current that the inverter must give. Okay, so if you look at here, look at this inverter here, you can see that this is a three-phase inverter. You can think of this part as a DC source like PV system, or you can think of this as a DC link, capacitor DC link, which connects between a rectifier and inverter. It can be any of these. So what are we going to do is that the inverter converts DC into AC, VA, VB, VC. And we have a couple of switches. We have upper switch and lower switch, upper and lower for each phase. What we would like to do is that after getting a reference voltage, what kind of voltage you need, VA, VB, VC, or what kind of current you need, IA, IB, and IC. Okay, these reference values are given from these values. Okay, so we select the reference voltage and the current based on the reference active power and reactive power. Where did we convert these to? These using scalar control, which we will see in the course, or vector control. Okay, now how can I achieve these values of voltage and current? Okay, it can be reference voltage or reference current, depending on the switching technique which we are going to use. So for example, we can use a switching techniques for current. So for example, if we are going to get IA reference, IB reference, IC reference based on these two, then I'm going to use one of the current control techniques like high stresses current control, ramp current control, or a predictive current control. These are different control techniques that will convert these reference currents into pulses to these switches here. Or if I have VA reference, VB reference, and VC reference, we can convert it using a voltage control technique like space vector modulation SVM, or sinusoidal pulse width modulation, or a selection harmonic elimination SHE. So these are some of the current control techniques, some of the voltage control techniques. Okay, now in this course I'm going to show you, for example, the high stresses current control by getting IA reference, IB reference, and the IC reference, and how we can convert it into pulses. And also I'm going to show you the sinusoidal pulse width modulation, how we can convert the three-phase reference voltages into pulses. Thank you for watching this lesson. I would like to invite you to our academy, Khadija Academy Premium membership, which will help you learn more about electrical engineering. In this academy, or in the academy membership, you will find that we'll have more than 100 courses in math, electrical engineering basics, power engineering career preparations. For example, we have electrical design, we have courses on electric circuits, power electronics, ETAB, MATLAB, solar energy, wave energy, wind energy, and much more. You can join our membership for just a small fee per month, or you can just have a lifetime access in which you will get all of current courses and classes, and you can have them forever. And not only this, but any new courses that will be created, you will be able to watch it for completely free. So what are the classes that I will learn in this membership? You will find different classes in electric circuits, you will find in transformers, magnetic circuits, machines, power electronics, load estimation, lighting design, lightning also design, earthing system, cables, generators, light current systems or low current systems, off-grid design, on-grid design. Very lots of classes and courses in different topics.